Welcome to the Brisbane Azure User Group. This session is being recorded, so careful what you say. The microphones pick up your conversations very good, so better than I can. That was that slide. So welcome to December. If you don't think it's December, you're probably in the wrong spot. Before we go too far forward, like big thank you out there to our sponsors. So without Codify and Microsoft, this would not be possible. So thank you very much. Being a community event, so we're trying to get as many people involved in this as possible. We've had a great year so far. Next year's shaping up to be even better. If you've got something you want to present, it doesn't have to be amazing. It doesn't have to be massive. It can just be really small. It can be about stuff that's old in Azure as well. So it doesn't have to be the latest and greatest, because it's really about what works for you. And people want to just hear, what's your best experience with Azure? What's something in Azure that's adding a lot of value, ideally associated to Azure. But yeah, we've had all sorts of presentations here, and we'd love to hear from anybody. So it's a great event. See if you can get involved. Talking about it helps you learn it. So it's an incentive. Yeah, exactly. All right, so a few updates. Well, actually, there's an enormous amount of updates this month. So rather than covering them all, because I'm just not, and there's just too much there to talk about this month, I'm going to go through my 5 top picks. Doesn't have to be your 5. This is just what I thought was really cool in Ignite. And happy to have conversation if people tried some of these or they like other things that aren't on this list and you kind of think it should be on this list. Let me know, because I want to hear from everyone. It's a community event. So getting right into it. This is my number 1 pick. Completely biased. And just disclaimer already, I come from a development background, so I look at this and I go, anything that moves us to PaaS and allows us to do it safely, securely, without IaaS, that's a great step forward in my mind. So network security perimeter, what is that? So we can actually put a network boundary around these PaaS resources without a VNet. And I think that's really cool. It's kind of cool. Don't worry, it's just like a lie that I'm telling you. But it wraps up a bunch of your resources that you put into this network security perimeter, and then you can write access rules. So allows, denies, and then the other part is association to the PaaS resources. The interesting thing that isn't documented, but when you get in and start playing, you can find out about it. One of the best rules is, it's a little bit broad, but at a subscription level, you can write an allow rule. So resources at that subscription level can access inside that perimeter and use these resources. You can also do IPs and all sorts of old stuff. But it's kind of cool that you can kind of go, yeah, I want these things to be siloed off and only accessible to this subscription. Pretty cool. Resource group would be cooler, but subscription's a really good start. So bunch of components involved in it. So you've got your perimeter, your profile, your access rule, your resource association, as I talked about, your diagnostic settings. They're okay. Opportunity for improvement. But it's really new, right? So it kind of works really well. It goes into a learning mode when you start. So when you actually put your resources in there and you set it up, it goes into a learning mode, and it'll sort of say, hey, these things are coming through. And then you can go and switch it into enforcement mode and lock it down. Yeah, I like that one. That's my number 1. This one here is sort of, I don't have a lot of slides on this one. It's sort of slipped through. It's kind of been bounced around for a bit. But sidecar support on app service. So app service is a great feature of Azure. I kind of feel like it's one of their strongest them's probably fighting words to a bunch of people. But App Service now supports those sidecars. So you don't necessarily have to go to Kubernetes or container apps or container instances, container apps. You can now start doing this stuff in App Service. So App Service for a while has been able to put a container up there and host a single container. Well, now you can host a bunch of containers, and you get that sort of boundary around them, and you can delegate off into those containers. So it's kind of massive. From a utilization perspective, this thing's probably something that's really big. So keeping it simple, App Service is your ticket. So App Service and Azure Front Door is kind of like one of the simplest, most secure ways you can actually do anything in Azure. It's great. This one here is one that I've been trying to ask about and find out about for a while now. It's massive, in my opinion, only, but I'm sure a lot of people agree. So SQL database in Fabric, so rather than paying money to have an Azure SQL instance and having to do all the maintenance and the support and the configuration and stuff that's already quite pretty easy on a PaaS service, well, now it's even easier, and you don't actually have to pay for it. Caveat, it's already included in your capacity units, but so if you've spun up a 64 capacity unit Fabric and you've got a bunch of cycles spare, like a lot of organizations, because they want to get that Copilot, but they've got a bunch of capacity there, well, this is a really good option. It spins up a SQL database. It's automatically mirrored. You can't turn it off. It's all part of the build. It's mirrored into your OneLake. I'm probably jumping ahead of myself here. There we go. That's a good sign. So near real time mirrored into your OneLake, and so you've got access to it from your data warehouse, and you can connect to it that way. But it's an actual Azure SQL instance. I'm going to jump ahead and go to security because that's more important. So from a security perspective, it is out there on the internet. Yes, doesn't have a VNet around it, but it doesn't allow you to connect to it with the SQL login. You can only connect to this with Entra. So from a security perspective, it's actually pretty good because your Entra accounts are pretty solid. So running OIDC in the background, and more importantly, already tested. You can spin up a managed identity. You can connect to it over a managed identity from a web app connecting into your database. So everything you're doing, well, hopefully doing in Azure App Service and SQL, you can now do it in Fabric. And the great news is all that data is just going straight in there. So you don't have to do any of that integration, hard lifting or mirroring or any of that sort of stuff. It just goes straight in there. What did I miss? That's how it looks in Fabric. It's got a SQL analytics endpoint. It's got a semantic model. So you can just hook in straight away. And you can use your tooling that you'd normally use for SQL. You can use that in this service here. So it's got connections in there from, in addition to that, because the Azure SQL web experience is kind of crap, but the Fabric experience is actually pretty good. So the Fabric experience is great. You can use SMS, SQL Server Management Studio. You can use VS Code, choose your poison, connect up. It's an interactive Entra connection. It's not, you can't use username and password. It's actually a benefit, not a negative, but it's a change in a lot of people's behavior. And then backup, by default, it's all just configured. It's all part of how Fabric operates. You're not changing that. But you can see what's going on. So from a monitoring perspective, it's really cool. All right, so container apps, private endpoints, that's now now sort of announced in Ignite. It's a pretty big deal. So with this one here, if you want to take your traffic in from the edge, route it directly into your container apps, which is running in a VNet, you can absolutely do that and have no internet traffic from that edge to Azure. That takes it all off network, off the internet, into private routing, all the way into Azure. So from a security perspective, coming back to logging a dead horse here, from a security perspective, that's really cool because you don't have that surface area of attack. Cool. All right, I'm going to go really quick because now that I've set everyone's expectation. Networking Copilot's really cool. You can actually see what's going on in your networks now, so that's pretty handy. And then I think this is the final one. So Microsoft's Copilots with all of the Copilot students at Studio and the agents. All right, so standard resources. It's taking a long time to go. Training resources, blogs that are pretty cool that you should definitely check out. And tonight, without any further ado, we've got Ben Parker and Lawson Kay-Butterworth. They are going to talk to us tonight about optimizing firewalls on Azure for secure, scalable hybrid networks. So Ben's been leading Codify planning and migration services, bringing over 15 years of experience working with Microsoft technologies, and Lawson's working for Codify's service delivery team. Welcome.
Cool. All right. Well, thank you everybody for coming. So today we're here to talk about running firewalls on Azure. And so as the introduction was, I'm Ben Parker, Director at Codify, and I've been working in Azure for quite some time. I've got my co-presenter here with me, Lawson, who works in our service delivery team. So he does a lot of the work I merely just talk about, or do PowerPoint slides, or send emails saying, yes, we can do that. For a bit of context, notes. Actually, I don't know whether you mentioned it in October, but it was the 10-year anniversary of the Azure Australian regions. So 27th of October, 2014 was when they launched. Back then, we were doing a lot of work with the Microsoft marketing team, so we were involved in some of that launch stuff back then. But I was sort of putting together this presentation, so trying to think, what was it doing 10 years ago? So probably launching some campaign around that announcement and release to the general service.
I think that's when Dan and I picked up the user group.
Yeah. Probably also had app services at that point still. So they're a staple. Today, back 10 years ago, we weren't doing everything in Azure, but today we most certainly are. So we have a plan, migrate, run methodology that we work with our customers on, sort of helping them, how would they use Azure, getting them to Azure, and then helping them stay in that operational success goal. And so today's presentation is largely out of that run pillar that we manage. We have as the sort of logo suggests, we have a number of partnerships and security credentials, and great to see the security heavy introduction on those Ignite announcements as well. I think there's no secret to the investment that Microsoft makes, and probably we're all making in this room for some capacity as well. This year we became a Fortinet partner as well, and so we've been working with those guys as they are a Microsoft partner too. Microsoft's all about their partnership and wanting to have refreshing sound, and they want to. It's all about they're building their platform, making it available to everyone. So the presentation today is really focused on our experiences in the field, working with Fortinets on Azure, and how you can cross the gap between what you might have as an impression about NVAs or firewalls on Azure that aren't the native Azure firewall, and bring that closing the gap between what is what is a separate virtual machine, and bringing that integration back into the Azure SDN. So I think we have 5 that we're going to go through today. Before we get into those 5 topics, I do want to just sort of set the scene, and this is really what we hear, right? we've used Azure Firewall. We still do. I think Azure Firewall has a great place. Certainly, it belongs in every deployment. A firewall belongs in every deployment. But certainly, when customers are doing a proof of concept or evaluating services, Azure Firewall is an option. It's a native option. It's quite quick and easy to spin up. We then similarly here, once we sort of do that POC and we've had some success, we then sort of hear that potentially it's not part of the cybersecurity wing of an organization because it's in Azure. It doesn't sit well with everything else that's connected on-prem, FortiGate or whatever else, and it's been managed by an Azure cloud team as opposed to a cybersecurity team. And those that are very familiar with sort of security frameworks will know that separation of duties is a big thing, and that's why we have a lot of those controls and why we want to do have unified panes of glass so that we can make it easy for people to deal with these things. It's also not the only thing that you need, and sort of once you progress like that in that maturity cycle, and appreciating that the audience I'm talking to today is all about Azure and might not suffer from these problems, but maybe something that your peers or your co-workers are dealing with is it's Azure Firewall is an edge firewall, but you can't VPN into it, so we need another service. And there's better ways to do WAF and front door that was mentioned before. So it's part of an ecosystem, right? And organizations want a centralized view of those. Certainly cybersecurity professionals do. And so that's probably what we hear most about in terms of the conflict and why we're talking about that today. Lastly, on this slide, why Fortinet? So we'll get to the 5 things that we're going to talk about, but it's really that the investment that Fortinet are making into their FortiGate products, and there are other product sets too, around automation, integration back into the Azure SDN, which we probably spend a little bit too much time talking about tonight, and just probably the fact that we see it in a lot of our own customers. They're already using them on-prem, so it sort of naturally became one that we would then look to in the cloud as well. Speaking of, a couple of case studies. So these are some of our Azure and Fortinet customers that we do work with. James from Mossman's got some great quotes about the work that we've done, but also in light of the FortiGate work that we did specifically on Azure. New South Wales Council, for those that don't know where Mossman is. For them, the FortiGate in Azure was their first Fortinet product. They had a legacy on-prem firewall. Making the transition to cloud, it made sense for them to evaluate something more modern, and so FortiGate was one we recommended and was chosen. The other reference.
Yep. As you can see up there, the lovely Louis is fantastic coder. He's a brilliant guy to work with, really enthusiastic. And so UQ Sport is the organization he works for. They manage the sporting venues of UQ, so the Gatton and St. Lucia campus. And yeah, he had nothing but lovely things to say about the FortiGate journey. They already had one on premises, and so it made total sense for them to stick with what they already knew and what they already had, and deploy that one in the cloud. And it just really streamlined their journey, keeping that kind of familiarity with firewall platforms, not having to learn something new. The native VPN that is just like 2 clicks and it's all up and set up. So yeah, we had a lot of lovely things to say about FortiGates. So the first thing we'll talk about quickly is a little bit of a fundamentals of what is different between on-premises and Azure networking. If you come from an on-premises background and you're really used to configuring switches and routers and access points, it can be a bit intimidating coming to Azure and going, where are my VLANs? I don't understand where all the networking controls I'm used to are. The main thing that trips people up, as I kind of alluded to, is in Azure, layer 2 doesn't exist. Everything starts at layer 3, so the network layer. It's designed to be easy to kind of get your foot in the door, right? Like Azure is designed so that developers can quickly and easily deploy their applications. They don't have to have 10 or 15 years of networking experience to configure all of the different products. It's kind of an afterthought of your deployment. As you're clicking through the menu to deploy your app service, it's do you want VNet integrated? And it just kind of happens without thinking about it. So to then take the next step and secure your network effectively and align it with your chosen security framework can take a bit of extra thought because of how kind of simplistic Azure networking can be sometimes. So on that, we kind of talk about a few different things here to highlight those differences. As I mentioned, layer 1 and 2 don't exist. Everything starts at layer 3. This means that all of your networks in Azure are flat. So any endpoint within a network can reach any other endpoint in a network by default. There's no physical separation. There's no even intermediate hops. When you go from when you do a trace route from one VM in a VNet to another VM in the VNet, they go direct to each other. There's no router in between. There's no gateway. So the next difference would be IP addressing. On premises, the IP address of a host is defined by a DHCP scope or the static address config in the operating system. In Azure, you try to avoid an operating system IP and network config. You want to keep it all defined at the network fabric level. So your addressing is defined by the NIC and then dictated to the guest via the network fabric. The last thing that trips people up about the kind of switch to Azure is bandwidth. On premise, you're very much tied to your hardware. If you have a 1 gig NIC, you can get up to a gigabit, right? If you have a 10 gig NIC, you can do 10 gigabit. But in Azure, you don't. It doesn't necessarily work that way. Your throughput is defined in the SKU of the product you're deploying. So if you deploy a 2-core virtual machine, you might only have a gigabit of throughput. But if you upgrade to a 4 or 8 core virtual machine, you then get more throughput. And by adding more NICs to the equation, you don't necessarily get more throughput. You just divide your available throughput between those NICs on the VM. So the last thing we'll talk about is the two kind of fundamental components of every VNet. Without these two things, it's pretty hard to have a VNet, a virtual network in Azure. The VNet or the virtual network is what defines your private networking address space. Typically with RFC 1918 address space, so your 10 dots, your 192.168s, your 172s, but you can bring your own IP if that's a requirement. Each VNet is sort of comparable to a core router or switch, where it defines all of your different IP addresses that are available on the network. You use VNets to build your hub and spoke network model. So each VNet would function as either a hub or a spoke in your hub and spoke model. And you connect them together with a function called VNet peering, which is how you join the two address spaces. And then they effectively act as one virtual network. But there are intricacies with how VNet peering works, so that if you have a hub and 2 spokes on either side, the 2 spokes can't natively communicate with each other. You need to have some kind of appliance in the middle to forward that traffic between the two. Finally, each VNet is broken into subnets. Subnets are exactly what you'd expect. They're a subnetwork. And in Azure, that's how you apply your routing and your what's called a network security group, which at its basic level is kind of like a legacy kind of firewall. That's you can set rules in it so that if you're coming from this source and your destination is this, on that port, this protocol, traffic is allowed. Anything else, traffic is dropped. It's very simplistic. It doesn't kind of do threat analysis or packet inspection. It's really just a very simple ACL. The other major component is a network interface. On-premise, you think of them as a component of the server, but in Azure, they're a function of the network fabric. So they're created as distinct objects from the servers. If you deploy a virtual machine in Azure, you'll get the virtual machine resource, the NIC, and then the operating system disk. So the NIC config is distinct from the virtual machine. As I kind of said before, that's where you configure the IP addressing and policy. So on the server, you set it all to DHCP, and it just receives what the network fabric dictates to it. And then in Azure, you can tell it you want it to have this static address. I want it to use this route table, and this NSG is supposed to be applied to it. Yes, so through the fabric, that's where you set all your DNS, your IP, your route table. Additionally, you can attach NICs to certain PaaS services. So as PaaS is kind of the way we want to be moving. It means that Microsoft gets to manage a lot of the things that we don't want to, backups and other things like that. So to be able to connect those into our virtual network and connect to them securely, and use next generation firewall appliances to monitor traffic to and from our SQL databases and other things like that is a real boon for us. The last thing I'll kind of prime you guys on is how load balancers work in Azure. They're actually really well done in Azure. Microsoft's are very, very proud of them. There's a fantastic video that I'd be happy to share with any of you that's about an hour long of one of the engineers who worked on the load balancer just absolutely raving about them. It's really very informative. More or less, the load balancers in Azure are software defined. So it's not a like an F5 appliance somewhere deep within a data center. It's all software defined. It uses a 5-tuple hashing algorithm. So that means that it takes 5 different inputs, which would be the source and destination IP of a connection, as well as the source and destination port of a connection. And the last tuple is the protocol, so TCP, UDP, ICMP. And based on the outcome of that hash, it will then select which backend the connection is routed to. And so if you vary any of those inputs, you may get a different backend each time. The
session persistence. Sorry, you keep going.
Yeah,
there's an optic and tick which persists session. So front end goes to one back end and all to all the others to that one. I thought.
The top one.
Yes. Top bottom of the screen.
there is an option.
Yes. What down near the bottom, the second last bottom.
In the diagram here, the different scale units kind of the load balancer are called muxes or multiplexes. That's what Microsoft refers to them as. And so the kind of flow of how a load balancer might route the connection would be, your internet client here. You do a DNS lookup for a service and it returns the front end IP of your load balancer. So you then route, of course, to the front end IP. That's attached to a load balancer. And so it then kind of sends you through to one of the scale units or the multiplexes. Your connection is then put through that hashing algorithm to determine which backend server host you should be spat out to. The load balancer will then send you to that server host. And that's a physical box within Azure's data center. On all of those server hosts, there's what's called a virtual filtering platform, or a VFP, which is a simple kind of security appliance that does some scanning on connections to make sure everything's above board. And then the interesting part of the default behavior of the load balancer is that the destination header of the packet is then rewritten to be the IP of the backend. So it is fundamentally changing how the packet is written right at the end. Which can be undesirable, and there is an option to avoid that with the option called floating IP, but that's probably a whole nother presentation in itself, so I won't go into that today. But then the very cool part of the Azure Load Balancer is that the engineers kind of understood that it was a bit inefficient to send the traffic back through the same path. It kind of wastes compute time on the load balancer, among other things. So using a bit of Azure magic that isn't really very well explained to me, it rewrites the packet to make it appear as though it came from the front end IP, and it returns directly from the server to the internet client. Very, very cool. So, Ben, I think I will hand back over to you now for some discussions on Azure Firewall Trusses.
Sure. So with all those things sort of in mind, and I guess we're still trying to paint the picture of what everything means. When we sort of initially might work with a customer around that migration, building out a landing zone and things like that for them, I think it's well accepted that hub and spoke is the architecture that we're all using. But that doesn't mean that we only end up with one hub. Those modern architectures where you've got transit DNS to get back on-prem through SD-WANs and things like that can still make it quite difficult. Like a simple hub and spoke is not always the answer. So the way we go about that, the way we approach it, is really by planning traffic flows. The next slide, sort of, as you might see from the last couple of last 3 words on that slide, sort of showcases what that might look like. But there's a lot that we want to consider when we're doing this flow planning, right? Ultimately, the thing we need to do is follow the guidance items there. We need to think about inbound and outbound from all directions around the compass there, north, south, east, west. We need to understand, well, for each of those, what is the source and destination being? Is it the top, is it the bottom, or is it within Azure itself? And we're trying to avoid complexity. That's not always possible to do, but we try our best to try and eliminate that wherever we can to get to that well-architected design. The important one there was really the second one, though. We don't want to paint ourselves into a picture where we're just using virtual machines in the cloud. Like, that's the lowest common denominator, right? Like, we're going to have some, and they'll be around for a long time, particularly in large organizations. But we want to enable the use of platform as a service offerings, and we don't want to just be painted into the corner where we're using service endpoints or private link or whatever. We want to be able to make sure that we can confidently and securely leave a virtual machine or managed instance or something like that and get to something that otherwise is on the Azure public edge. When Microsoft released those preview products, don't know exactly how many of these would be on your list, but when they release those, they start off life on the edge of the cloud, and then they sort of, as they mature, they get brought back in, and arguably people would say that's becoming enterprise ready, but I think there's architectures that you can deploy that will accommodate that as well. So the next slide, I don't think probably requires a whole heap of explanation. But when I say we've got to plan traffic flows, you're not meant to read it. But you can if you desire to. But the idea there is, like, we want to start planning these flows, and that's how network traffic engineers. That's how they think. They're thinking about how does something from a source get to a destination? What's the routing profile look like? As Lawson sort of introduced in sort of the primer there, it's a flat network, so we need to accommodate for that. It is a hub and spoke diagram with a lot of extra lines hanging around it, and that's sort of what we want to gravitate towards. The long list of verbiage that is there is really the succinctest way that we can possibly explain that network flow in each of those individual scenarios. And if you can sort of have that, you can then sort of plan you can sort of, as a new project comes along or new services get lit up in Azure and you want to start using them, you can start picking them from this list, and you can sort of say, okay, well, the security profile that we're going to apply is, going to meet the black line going out to the Azure Platform Service in those preview cases, as an example. But that's sort of what that looks like. The challenge that we have, if I go to, oh, no, not yet, still not challenges. So the options, and if I think about what was at the middle, what was that firewall appliance right there in the middle, it is what you're faced with when you sort of build in these designs. There is the Azure native, Azure Firewall, which I talked about before. We still employ them in proof of concepts. It's a simple one-click deployment, right? Like, it's native, built into Azure. It works. It's fully integrated with the Azure monitoring suite. It, however, is not a next-gen firewall. There's, follow that QR code if you wanted to go see some sort of the statistics about some of those products, and it goes into the other cloud providers as well. But make no mistake, it's not a cloud. It's not a next generation firewall. That doesn't mean that the NVAs have always been a different option. So when we talk about network virtual appliances, we're talking about FortiGates tonight. We think about them as virtual. While Lawson spent so much time introducing that topic around VNets and computers and NICs and things like that. So they're deployed from the Azure Marketplace, which means we can license them and have them readily available. There's no retraining for our staff. We can pick them up and use them. They're arguably the same interfaces, which means that they're bespoke, but you get the benefit of being able to maybe accelerate that cloud adoption journey. And the configuration is therefore proprietary. So they look the same in the product that they are, but if you go to a different product, it's a different thing. The 2 lines that have struck out there are really where we start talking now about what is the story for tonight and why are we talking about this stuff at an Azure user group. So historically, they did not integrate at all with the Azure SDN full stop. And the HA story wasn't great either. The complicated architectures with load balancers, In the case of, floating IPs between them and sort of, relying on service principals to connect to fail over, it was complicated and arguably slow. You'd have to wait for the secondary node to work out that its peer was offline, and it would have to take that configuration and apply it to itself. The story now is then, well, how have those two things changed, and what can we do that's a little bit different? Go first, good.
So there's two different ways to navigate HA. Many of you may be familiar with active-active, active-passive, but I'll assume there's some who are not. Active-passive is where one firewall is processing all the traffic, it's actively receiving the connections, and the other one is in a standby mode. It's passive. It's waiting to understand that the active has had an issue, and it is going to then seize the active role and begin to process the traffic. The alternative, of course, is active-active, and you can have active-active, active-active, active-active to the nth degree, because the way that traffic is spread between those hosts is with a load balancer. And so the hashing algorithm that I went into a lot of detail about before is what determines which of your scale nodes is receiving the traffic, and likewise on the way back in. So it can be fairly easy to misalign your chakras and get your routing asymmetrical. That can be a big party foul for TCP, where your connections need to be monitored both ways for it to be stateful. In scenarios where in Azure, where a virtual machine or a service has multiple equal cost, equal prefix routes available to it, it uses a protocol called ECMP, which is equal cost multipathing. However, it doesn't guarantee a symmetric return, and the same is the case for the load balancer. If you think about, a source and destination IP and source and destination port and protocol, if you then flip that around, you get totally different inputs for a hashing algorithm. A hashing algorithm's not smart enough to figure out that some of those inputs will be the same. It's just on the inverse. So you'll get a totally different output of the hashing algorithm, which may then mean you end up on a different one of your firewall backends in an active-active situation. The way to work around this is to use active-passive. If only one of your firewalls is actively receiving traffic, there's only one thing that the load balancer is allowed to route it to. And the same can be said for the route server. There will only be one valid route back out to the internet or back to the other side of your network. The alternative is SNAT, which is source network address translation. Unfortunately, that it rewrites the source header of every packet so that the server receiving the connection sees the firewall as the source of the packet. And for your application logging, that can maybe not be desirable. If every connection is coming from your firewall, it can be quite difficult to determine. We do a lot of analytics based on geolocation of our customers. That's quite hard when everything's coming from your data center. You need to use different things like exported for different headers, but your application may not support that, or your devs may not want to, may not have the story points to put that in. Whatever the case is.
One joke always goes down.
Yes.
Okay. So long story short, we're big believers that load balancers, particularly the internal side with NBAs, is not a great idea. And if we think about like the OSI model, which I'm sure most of you know about, you've got 7 layers that go from everything from a physical cable all the way to you're looking at a TikTok or Instagram, right, all the way through. As Lawson explains, we start at layer 3 in Azure. And ironically, that's what we also want to load balance. We're trying to load balance the layer 3, which is the default route, and put that into our network. The problem with ILBs is that they need to actively monitor the health of the backend pool. That is a layer 4 connection because it's TCP generally. You need to be open to some port in the backend. So what you're doing is you're taking a dependency cross layer, which don't do it. Like outside of cloud, anywhere in computing, that's a no-no. It's a design flaw at that point. So our point of view is to no longer use internal load balancers inside Azure deployments for NVAs, and instead looked at Azure Route Server, which allows us to do BGP relationship into Azure that where our FortiGates can peer into. I'll just stall on the next slide. There you go, Azure Route Server. So Azure Route Server is kind of the hero of this story, and it's how the FortiGate solutions can then interop with the Azure SDN from a traffic destination next hop perspective. Behind the scenes, I'm sure it's a couple of RAS boxes maybe that are configured with a BGP endpoint on it, so that you can then create a BGP peer from your firewall into the Azure Route Server, and then you can, from your firewall, advertise routes that are accepted by the Route Server and then propagate across your network environment. The really big win outside of the don't take dependencies from layer 4 to layer 3 as an example. The other really big win is you move away from route tables. I think the number of environments that you see or probably already are living in as well, where by default everything's going to go to the internet in Azure unless you've got that route table on there. This flips it the other way around. By default, you're saying the next hop is going to be an IP address, the IP address of your firewall, and everything will route directly to that for a next hop to the internet. And you can also, with sort of as this diagram's alluding, bring in your SD-WANs, your ExpressRoutes and things like that, and manage that flow of traffic as well to go back through the firewall. I think that's about it.
Excellent. So it is very likely that at some point you will be asked to connect your cloud environment to on-premise. You might have some legacy servers on-prem. You might need direct connectivity to an application that you're running in the cloud, whatever it is. At some point, it's fairly likely that you're going to have to actually physically connect to your stuff in the cloud. You have a few different options. The first one we'll talk about is ExpressRoute. That's what most people consider when they think about connectivity back to on-prem. It certainly is a very good option. As I kind of alluded to there, it's integrating the cloud to your wide area network. It's a high-speed connection between your premises and all of Microsoft's cloud services, so not just your private network in the cloud. When you provision these services, you provision the bandwidth you require. And that bandwidth is guaranteed, so you don't have the fluctuations you might with a VPN. It's consistent, and you get a lot of scalability, because if you need more bandwidth, you can just provision more bandwidth. It works by connecting your infrastructure to a meet me location, where Azure has a kind of endpoint that you can connect to their network. And the two, as I mentioned before, the two different parts, the two different types of peering you can have. Private peering, where you're connecting your private network to your private cloud, which is the bottom down there, where you can see the Azure Virtual Network Services with a virtual machine and app service, storage account, etc. And then there's the other part of it, which is Microsoft's SaaS offerings in the Microsoft peering. So if you have, you want a direct connection to SharePoint, or you want a direct connection to Dynamics, or whatever it is, insert as Microsoft, SaaS Microsoft product here. That's a fantastic way to have provisioned consistent connectivity to those. By default, ExpressRoute and Route Server do work very nicely together. Perhaps too nicely though. We had the opportunity recently to go through a process of building this architecture with a customer, and it certainly came with a few challenges that we had to overcome. At the top here, you can see kind of what we started with, which is everything in the hub network, which is what you'd expect. We've got an ExpressRoute gateway here connecting to a ExpressRoute circuit, and then there's on-premise represented here. The issue we had is that by default, Azure Route Server creates a managed BGP relationship with the ExpressRoute gateway. So it will automatically learn all of the routes that your ExpressRoute gateway is advertising, and it will also learn all of your spoke networks as routes and advertise them back to the gateway. And what that effectively does is totally bypass your firewall. So you have a very expensive FortiGate firewall that your security team is very proud of, and it is not processing any of your east-west traffic to and from your backhaul connection to on-premise. We had to do a bit of creative thinking to re-architect this, but in the end, we found the option. The solution was a VPN connection overlaid over the ExpressRoute. So when you're configuring the ExpressRoute connection, you want to focus on the minimum, advertising the bare minimum possible to the BGP peering between on-premise and your ExpressRoute gateway, just enough to bring up the VPN connection. So you want to advertise the network that contains your firewall in Azure, and likewise on-premise, you want to advertise just the network that contains your firewall on-premise. That's enough to bring up your VPN connection and establish another BGP relationship over that VPN. And through that VPN, that is how all of your on-premise routes are learned. And likewise, the route server advertises all of your Azure spokes through that VPN back to your on-premise network. And that is how you can have all of your east-west traffic inspected by this firewall.
Does all the traffic flow through the VPN?
All the traffic flows through the VPN, yes, except for the IKE traffic, of course. And you can have direct connectivity between your Azure anything in your hub network can have direct connectivity back to on-premise. So if you had a Forti manager or something on-premise that you wanted to connect to the private IP, you could choose to do it that way. Ben's got a great part to talk to.
So if that's how we get the actual networking side integrated, and that leaves then probably the open question mark of, well, what about all the Azure dynamic, the cloud's dynamic? We want to leverage these things accordingly. Oh, I did go the wrong way, did I?
You did. Sorry, I got you sorted.
Thanks.
Maybe I didn't. There we go. Now I did.
Yeah, cool. So essentially, what we're doing here is we're sort of relying on sort of infrastructure as code and two sort of platforms that we bring together to make work accordingly to automate our deployments. So Bicep and ARM, I'm sure everyone in this room is familiar with at least, but they're our chosen platforms for infrastructure as code in Azure. And in the FortiGate space, we have the CLI and Ginger 2 as their automation platform as well. So we can build an end-to-end orchestrated deployment of our secure hub that we then can drop in our peerings into and merge things along. What you sort of see here in these two screenshots, the middle one there is, the one with the blue and green is our ARM template. And you can sort of see it's referencing a virtual machine object, as we sort of discussed before. But we're able to inject a custom data file into the provisioning process, which allows us to then get FortiGate configured with the same variables and the same technology, which is then the item on the right. So it's that custom data blob, that variable that we're passing through. It's built further up. You all know ARM templates; they're quite long, don't fit on a screen nicely. But we then have that. We then have that script that gets run as a custom blob, a custom data attribute, and then is executed by the FortiGates when they boot up for the first time. The things that we can do as part of that, I mean, you're all familiar with the Azure piece, right? So we're building the virtual networks. We can build the route server. We can build the VMs. We can build all those NICs. When you build firewalls in Azure, those NICs need specific configurations, like IP forwarding allowed and things like that. So that'll all work. You can build all that into your ARM template, which would be there. And then we go over, and once those virtual machines are started up, we can then start doing all of the FortiGate interfaces as well. So giving the interfaces the appropriate names, internal, external, HA ports, things like that. We can, because we now know we have context of the Azure networking, we can say, well, we know the subnets, we know the next hop in each of those, the .1 address of each subnet is the router, or is the SDN router, I should say. We can configure that as the next hop for each of those FortiGate interfaces. And then we can start doing NAT policies and things like that, or within the FortiGate and building out all of those rules. The next one we can do is we can build out our Azure SDN connector, a little bit more about that in a second. And we can also do licensing. So again, marketplace, you can just buy it through buy your licensing on pay as you go as you start, but you can also install that license through the same scripting languages as well. So it becomes sort of an end-to-end solution. Why do we want to do this? Well, it's quite easy, as we talked about deploying Azure Firewall. It's one click, and if you create a new VNet, I think it's even an option as part of that. And I think it might be 2 clicks because you've got to specify a public IP. We want to get as close as we can to that. We don't want to treat anything in Azure, particularly our firewalls or our core networking infrastructure, as pets. We want to treat them as cattle. There's cases where we want to, build a new one and do a hub swap, and we want to be able to have that infrastructure as code template available for us to just pick it up and run away with it again and build a brand new one. Whether we want to test the latest release or things like that, where that's able to be done as well. The next one then is the Azure SDN connector. Oh, questions.
I just have a question. So about the custom data.
Yes.
So with Bicep, maybe you could load in a separate file, which then have the configuration. Is that how you do it, or are you sort of like building on a standard string and then doing like replacement or something?
Yeah, there's a lot of concat going on.
Yeah.
Yep. So concatenating variables, which we're then using. We want to build out the VNet, and we want to build out subnets, and we know we want to have external transit trust and whatever. So we know what the definition of each of those are, and so they're parameters that we will have specified in the parameter file essentially, and then from there we're concatenating those into what would be those variables. So that's actually not what the script would look like on the FortiGate. That's more an interpretation of what it would look like compiled in Azure. Just made a little bit neater by removing the new line options that are always going to be there. In reality, it's just one long string. Yeah, but you have to cut it up a bit. Yeah. There are some other special stuff. The FortiNets have actually got a really detailed developer network, and on there that sort of talks through the structure of these files. Like they need to be, base64 encoded, but they need to have headers and footers that will, essentially inform what needs to happen as part of the process. It's probably the extent of my knowledge on them, but you can find others.
Yeah, no, understood.
Questions get rockets. Shit, was very good.
Now that you say that, I got two. First is that we've had FortiGate configure with Citrix, because a lot of clients have Citrix on-prem and then they migrated to Azure, and then when you have a FortiGate backup solution in Medtech, what happens to Citrix? Because Sentinel can't see it.
Okay, that's very specific. We would probably first off try and convince them to move to AVD, but that's just us. If we lost that bet, I'd have to read about Citrix. I'm not a Citrix guy, so
Okay.
I don't know what they're else.
Yeah, but FortiGate does FortiGate see UDP, TCP, or just
Yes, yeah.
what?
Yep. And because we're not using a load balancer, we can also even talk ICMP.
Right. Okay. Much. But generic one question.
Okay.
So you looked at the side.
Okay. Yeah, that's fine.
Where do the MBA sit on the shared responsibility module? For example, I'm on a security team responsible for vulnerability management, and I'm not picking on FortiGate. Allies, everybody in that space has had their issues.
Yep.
Do I have to still patch the MBA?
Yes. Yep. It's a virtual machine, so like it's an IaaS model of responsibility. Microsoft aren't going to take that on for you. We automate it so that we can patch and have confidence we can go back easily, which is sort of part of the reason why we invest in the ISE around these things. But yeah, it's certainly customer responsibility.
Yeah, like I said, I assume would be a big help in that space. But yeah. Cool. Thank you.
Your SDN connector may answer it, but
I've got it's too many.
you had load balancers in the active passive and active multi-active through the load balancer. I didn't pick up on the later diagrams with the route server. You only had one little firewall picture. So how do you do the HA with
Route server?
route server?
Maybe it was there, maybe it wasn't, I can't remember, but it'll be essentially 2 BGPs in. So each firewall is
Okay.
peering in to the Azure Route server.
And when it runs down, BGP adjusts appropriately. Okay.
That's right, yeah. And there is still a load balancer in that equation. You still have a load balancer on the external side. The internal side load balancer gets replaced with the route server, which is what then determines from the internal side of the network what routes are valid to go out to the internet. Yeah.
Okay. The second question.
Yeah.
Since you work in Mosman Council,
Oh, yes.
yes, do you have the pleasure of doing the RSA?
Sorry, doing RSA.
RSA service for tokens?
No.
Secure logins?
No, we've got a section on Entra ID coming up.
Right.
So moving from, so putting essentially MFA on top of FortiGates for administrators and things. Stay tuned. Next, I think it's the next one.
Yeah, will be.
The changing it to CLI, or is it sort of similar to Narnia? Or like
Sorry, say that again.
similar to Narnia?
I'm not sure.
Changing it to
Oh, I'm not sure.
yes, for firewall, you get to do like groups and different regions.
Yes, yeah, and we get the dynamic stuff in that next slide too.
And the other one was that first slide, but they backend for back to the client. So via cookies.
In the load
Oh, the
balancer.
load balancer.
No, I don't believe it is. It's a technology called direct server return. So rather than routing everything back through all the load balancer stuff, Azure has kind of maybe through a cookie. It wasn't explained to me, but the server rewrites itself. Sorry, Azure rewrites the source of the return packet to the front end IP of the load balancer, and the Azure Network Fabric routes that connection directly from the guest virtual machine or the service or whatever it is, directly out through the Azure Edge network back to the client.
Sorry.
All right. So Azure SDN connector. So Azure SDN connector is, so if we talked about how we now get traffic to go to the FortiGate as the first thing when we're using Azure Route Server, so that's pathing and network flows. The other thing that we want to have access to, which our Azure Firewall will have already, is we want to have the definition of all these dynamic objects that we have in the cloud. Azure Storage, Azure Service Bus, you name it, like all of those services have dynamic ranges that Microsoft manage, and we don't want to be managing a whitelist anymore, right? You can go and download the XML file, and we've done some bad things in the past, but we want to make sure that we can inherit that from the platform itself. That's what the Azure SDN connector does. So you can deploy a service principal, connect it up to your subscription. That's basically giving the FortiGate software the ability to log in and start interrogating those dynamic objects and start building their own object for you to then use in firewall policy. So, I've got a virtual machine. It needs to get to blob storage within a particular region. I can just use that dynamic object in my rule. I don't have to have a list of IPs, or I don't have to go and manage a static object set anymore. Also, which I think is a good thing, you can start using it for routing profiles as well. So you can say, I want to not send that out the external NIC. I want to send that out a DMZ NIC and start using service endpoints in Azure on those VNets or on those subnets within a VNet. And now you're not paying egress for your load balancers, which, depending on what you're doing, if it's storage, probably a lot of things. So it's a way to optimize the traffic flow, optimize the cost in Azure, and arguably avoid a lot of it in terms of egress out to the internet.
So in service packs.
Yes.
Somewhere you can see the screen. I think it's at the gateway. You nominate what services get publicized. So that has to align. That is the set that FortiGate will see, or will it see the whole lot and you have to manage what you don't want to be advertised like this?
You have to manually create. Well, not manually create them. You can start creating and then reuse them as like an object inside the firewall policy. So you would have to make whatever that is, API management, but you'd have to then make the storage
Oh,
version as well. So you define them, but it's using that dynamic object site. So in that image, you can sort of see the Azure One words or one down.
yeah.
That's the definition for the Azure SDN connector. So you fire up your FortiGates, you navigate to the right spot in the GUI, and you make one of those, and that's where you punch in your what is it, the app ID and service principal, that detail, and that connects the firewall to Azure. You've got to do the RBAC roles obviously as well, and from there it can then read the definitions that Microsoft make available in the SDN for you to then create these objects going forward.
Oh yeah, what I was probably alluding to is that you have the facility to short, you don't tick all the boxes on storage, global, whatever, blah, blah, blah. So if potentially one let loose, it could potentially see all periods, all announcements that would be different to what you'd set up at your, is it the gateway you set it up at?
On each subnet, you enable service endpoints because you also have to do that too.
Yeah, okay.
So if you want to, yeah,
different ends to something.
that's it. We can explore later. I think it was all on the side. Right. Getting on to SSO. So once our FortiGates are in the cloud, we can then enable a XAML relation, or we can enter in a enterprise app and then build a XAML relationship back with Entra ID so that both our administrators, when they're managing the firewall, and our users, if you're using the Forti VPN client, as it seems a lot of our customers also do, that is now using their Entra ID credentials, which means that you can then start overlaying those other security features around, I want to make sure I've got conditional access policy. I want to make sure they're coming from trusted connections, known IPs, and all of those things. So I can build all of that into it. Do you want to talk about break glass access and using Bastion and things like that?
Oh yes, yeah.
I don't think we have this scripted, or do we?
I do have a slide about it. Yeah, SSH keys. So Ben's kind of jumping the gun a little bit on my slide here. But Azure really does have quite a good integration with or way to manage SSH keys. So you can create them at the VM's creation, and it will store the public key as a resource in Azure. And then if you don't want to store the private key on your local machine, which let's face it, you may not want to, you can use a resource in Azure called a key vault, which is where you store all your secrets, and you can use Azure RBAC, role-based access control, and key vault access policies to control which users can and can't access those keys and secrets. As Ben was kind of alluding to, there's a really great integration between Azure Bastion, the managed jump host service, and Azure Key Vault that will allow you to fetch those keys when you're logging into a virtual machine. So rather than typing a password, you select the key vault you'd like to get the secret from, you select the secret, and then without typing a password ever, you're logged into your SSH'd into the management interface of your firewall very, very securely. Using SSH keys allows for passwordless login, so there's a much lower risk of brute force attacks, particularly if your management interface is open on the internet, which is maybe not the most recommended solution. The other great thing is that using Azure Bastion allows you to take that management interface off the internet. You have a secure jump host in Azure Bastion, and you can use that to SSH with your SSH key directly to the management interface. And provided you've got all your 40 CLI commands memorized, you're sweet to go. And yeah, there's no need to expose the management interface to the internet. So it's fantastic.
That actually drops a keep error type match.
Yes, keep air type match. Yeah, so the public key is stored on the virtual machine, and the private key is either in Key Vault or on your machine, and you present that. Yes, that's right. Yep.
If you're hitting the Fortinet device via SSH, presumably management making changes, do you have a CI/CD option making your changes via code?
Yeah. Well, you could certainly just log in. I mean, I don't know how you log. You could probably SSH into it with the key, the key vault as well. But that's we're at the scenario we're doing is more of like break class process.
Yeah.
We would prefer everyone obviously use their Entra ID. But if you're doing
I want to do it change control by a CIC.
Yeah. So, well, you go back to your scripting language and then you can start pushing it in there. There is APIs that you can push. I don't know too much about those. If talking about looking at the gentleman in the FortiGate shop behind you, I might know the answer.
That's cool. Yes. And there's about 500 or 600 basically playbooks in the repository.
Oh, yeah, that makes sense. Yeah.
Yeah, I'm sure there's a tie into Azure DevOps and everything. That side.
Yeah.
Cool. Thank you.
You anyway. Essentially.
Sentinel. Hey, lovely. So for those of you who don't know, Azure Sentinel is Azure's kind of native SIEM product. It comes with native integration with all of the things you'd expect, 365, Azure. It does have native integration with a lot of other services. So if you prefer to use one SIEM product rather than 30, you can absolutely do that with Sentinel. It supports, like I said, data connectors from all manner of things, Azure, on-premise, third-party solutions. It's not kind of just a cloud-only thing. There's lots of automated IR playbooks that you can build. If you're not a if you're not a level 10 ninja that lives in the code, you can use low or no code logic apps in Azure. So you can just click and drag tiles and you input your parameters for certain things, and you can build automated playbooks to respond to detections on your network. It comes prepackaged with really easy to operate integrated interactive dashboards. And there's a whole suite of different alerts that you can configure there. For those of you who are familiar with Custo and the Custo query language, there's also the option to go through and build lots of threat hunting tools with Custo. And the fantastic part about Azure Sentinel is it's got that pay-as-you-go licensing model. There's not a big upfront cost for your security team to start monitoring your stuff through the SIEM platform. FortiGate, the reason I brought it up is because FortiGate has a fantastic integration with Azure Sentinel. As I kind of mentioned there, you may choose to replace your FortiAnalyzer with this if you only want kind of a SIEM integration, but there is also a place for FortiAnalyzer to enrich the logs before you send it to your SIEM. The SIEMs are very powerful when they handle all of your log sources. It makes sense to have all of your security logs in one place so that you can query a large data set and really tie together all of your different detections. The way that FortiGates work is you forward either syslog or CEF, so they're the two pretty standard formats, from your FortiGate or FortiAnalyzer to a forwarder. And then there's a connector that you deploy through Azure Sentinel that will receive those logs. When you deploy the FortiGate connector for Sentinel, there are a lot of built-in reports and dashboards. You get to take advantage of all of Microsoft's kind of up-to-date threat intel. They have a vast database of threat intelligence and emerging threats, and they're in a really great position to be able to detect new and emerging threats. Being that they're one of the largest tech companies in the world. And there's lots and lots of third and first party solutions. So if you find this solution there's kind of like a community driven marketplace for solutions in Sentinel. So you're not just reliant on vendor X or vendor Y developing a solution for you. You can if you find like-minded people in the community that are developing something that you like, you can deploy it in your environment. And again, if you're that level 10 ninja that lives in the code and loves to build things yourself, you can develop your own solutions. As long as you kind of spend a bit of time learning the query language, it's very, very, very powerful. And I think that's everything we've got for today.
Yeah, so I guess those 5 things, like the idea, the idea wasn't to come and say, get rid of your Azure firewall and install FortiGates everywhere, but it's to give the other option, right? I think those 5 pieces, so reaching out to route server, giving you the ability to default route management in Azure, You throw in the ISE capabilities and join that with the scripting that is available in FortiGates. You start adding the Entra ID stuff so you can get SSO to it. And, you know, we're able to securely manage who's logging into these things. We then had the Azure SDN connector, which enriches what rules, both policy firewall routing, but also, firewall policy and routing topology rules. There, and what was also, and then integration with, you know, Sentinel and the Azure monitoring suite. But it's though, when I went back to that sort of 7th, 10th slide, which sort of where we crossed out those two, HA was hard, and there was a sort of no real easy, you know, load balancing algorithm. I think those 5 have sort of eliminated those 2 pieces. That's what we're hopefully to demonstrate to you today. So, cool. Lots of questions. If there's anything else, let us know. There's plenty of rockets, and I don't want to take them back.
Instant-degree firewalls is like, you know, from subnet to firewall to subnet to firewall, stuff like that. With the architecture you have, are you sort of eliminating or minimizing input into network security groups? Are you doing things like a default route within a subnet to always hit the firewall and all of that security being centrally managed at the firewall as opposed to the curation of each of the subnets and VNets?
So we're definitely eliminating route tables. So route tables no longer point you to your NBA.
Yeah.
Route tables are used to bubble within. So instead of making sure if every subnet's got a route table, you are making sure every subnet doesn't have a route table anymore. So that's a change in philosophy. NSGs we still use, but we use them for like microsegmentation. So within a VNet, we're not routing, you know, different subnets back to firewall within the same VNet. We're using NSG at that layer to do backlinks, essentially.
And
that's how we do it.
Okay, and sort of like VNet peering, where you say your firewall's in the VNet, but there's subnets within that VNet. The VNet peering is something going from VNet 1 to VNet 2, where the firewall's existing, but the VNet peering will, in my mind, want to go directly to, just like you gave the example with the trace route or whatever, something will jump across. Will that behavior still happen with the route server in place? Will it still want to go directly, or is there some other tricks where what I'm doing is my security colleagues are wanting everything to hit the firewall and go back out again? So even a domain controller doing a group policy sysvol thing, they want to see that all go through the router as well, which I don't really want, but I'm just wondering.
You can have that argument.
Yeah. So VNet peering will still give the same behavior with the architecture.
We don't put anything else in our hubs.
We try not to.
Yeah, just firewalls to avoid. You know, don't put a DC there because it will directly get to it. I mean, you could do what you're saying, but you have many VNets.
Don't put a DC anywhere anymore.
Well,
yeah, that's actually the advice.
We're on board with that. Yeah.
Well,
If you could avoid it.
well, you've got to, like AVD, you sort of need to have a DC to authenticate to the workstations. Yeah, the Entra to get there, but afterwards it's domain to work.
Yeah. So I mean, just many spokes would be philosophy, I guess.
Yeah.
The hub is really only for your NVA. You know, you might consider putting a WAF there if you needed that capability as well. But if you put more things in there, the route server is then learning those routes and advertising them to the spokes. And so if you're having all of your core services in your hub, the route service is going to go, oh, look at all these things that I can, give you a super low cost route to. Let's go straight there.
Yeah. The engineering was laid out, or the sprawl was laid out before I got to it. So
that's always keep pulling on the string, you'll unravel it eventually.
Hey, can I add something?
Yeah.
Say you've got like 5 of these FortiGate VMs or whatever you want to call them, and if you've got some UDP traffic like quick, is it up to the FortiGates themselves to like heartbeat the load balancer. Like it does a hash of the tuple. So, you know, you're seeing one of your FortiGates is down and only one, but like 20% of the traffic isn't getting through. Is it up to the FortiGate like to heartbeat to say it's okay, or like how's that traffic ever going to signal that it's?
There's two directions you can be coming from, and I'll assume we're using the route server in this example. So one of your backends is unhealthy. How does it then kind of make it known that it's unhealthy? So the load balancer, as you mentioned, has that HA port that it's using. So it's sending TCP connections to the firewall saying, you know, can you respond to this? Can you respond to this? Are you alive? Are you alive? And when it doesn't respond to a number of probes, it removes that firewall from the backend pool and it will no longer route traffic to it. Likewise with Azure Route Server, it's a BGP relationship. So if the route is not valid, if the BGP information is not being exchanged, the Azure Route Server is not learning that that is a valid path to send traffic to, it will stop advertising that route to clients.
Okay. So that functionality of the heartbeat responding thing is built into the
load balancer. Yes.
Sorry, into the FortiGate as well, or do you just dominate?
You have to have the port
Yeah,
as
you
well.
got-
So
yeah,
it listen to.
Yeah, so it'll be like some sub-process that's listening, which is part of the reason why we don't like it.
Yeah.
Because it's like that sub-process could fail.
Yeah.
But the routing function, like the file function, is still fine. And so,
Or the other way around.
It's worse the other way around. Yeah.
well, look, yeah, absolutely. That's why we're advocating don't do that, because you're load balancing the wrong thing. You should load balance stuff through.
So how do you go about detecting and destroying and recreating the node?
Well, hopefully it doesn't get to that. But that's a bad bet.
That's where real bad.
Yeah, so
Yeah.
we would just go to ISC for that. So we built another one. Essentially.
It would allow you to deploy another virtual machine into your availability zone,
So-
whatever. it
So
is.
not necessarily automated responding off that heartbeat. It's more manual intervention.
Yeah, similar to that. So in a fail scenario, I mean, with Azure, so
BGP, like if it's not routing, like is there a mechanism to just like go, hey, maybe that process has failed, we don't know about it, or something. Is there a recovery?
so the BGP doesn't route itself; it just advertises how to get
How
something.
to get there? Yeah.
So when one drops off, it doesn't exist in pooling. So what you got to monitor from an operational point of view is you've got in Azure Route Server, you specify, hey, these are the connections you're allowed to receive, which would be FortiGate A, FortiGate B, FortiGate C, D, how many of you want. And if they disappear, that's a obsolete.
Yeah. Okay.
That would be how.
And then rectify on that and spin up a new image.
Yep.
Okay.
Yep.
That screen where you had the FortiGate HA on-prem to cloud using ExpressRoute, and then you had a VPN that you had to do.
The overlay VPN, yes.
That's right. Yeah. So ExpressRoute is essentially marketed as a non-public exposed private connection with encryption and all that. Of course, it doesn't do filtering. This you chose to go through the VPN. And can you tell us a bit more about what was the specific need from the client which helped you? Yeah.
Oh, yeah. I can tell you all about that.
Yeah.
So the going back to this slide, the main thing that killed us in this circumstance was that Azure Route Server intrinsically forms a managed BGP relationship with your ExpressRoute gateway. Your ExpressRoute gateway is how you represent the connection back to on-premise in Azure. So it's if you want to send traffic to your on-premise network, your next hop is the ExpressRoute gateway. So by having your route server and gateway in the same network, they learn and exchange information from each other. So your route server learning routes from your spoke networks. So in this image, it's this guy here. Azure Route Server's kind of learned a route about that network, and it's then over this managed BGP relationship, advertising it to the gateway. And so if the gateway wants to get to that virtual machine, the path does not include the FortiGate firewall. And so the traffic goes directly to the virtual machine from the ExpressRoute gateway, and you don't get the firewall inspecting any of that traffic. It's not able to do any of its threat detection policies. It's not able to evaluate if the ACL is valid. It just goes direct to the VM, and there's no traffic policy enforced on it. So the kind of reason why we needed to use that VPN is because to work around that, we needed to limit what information the route server and ExpressRoute gateway is exchanging with each other. So we only want the ExpressRoute gateway to advertise the routes to the hub to on-premise, so that the only thing that can be connected from on-premise to Azure over the ExpressRoute is the hub. So that's enough to then bring up a VPN connection over that ExpressRoute. It's an overlay VPN. And then the route server is learning about routes from the spokes. And because you then have a BGP relationship with the firewall, it's advertising those routes to the firewall, which the firewall in turn is advertising over the VPN to the other BGP peer on premise. So on premise is then learning about those routes via the firewall rather than via the ExpressRoute gateway. And so when server one on premise wants to send traffic to virtual machine one in Azure, the flow should go on-premise firewall, ExpressRoute circuit, ExpressRoute gateway, firewall, and then virtual machine, rather than on-premise firewall, ExpressRoute circuit, ExpressRoute gateway, straight to virtual machine. You have to go through that VPN tunnel in the second example, which is how we ensure that the firewall is expecting that traffic.
So with the ExpressRoute, you still have like primary to secondary paths.
Yes.
So does that complicate it now? You say primary darks and your secondary has to spin up
I
VPN.
I don't think so, because that's all like it's before the gateway.
Yeah, it's invisible to you as the customer in Azure.
I think it'd be not anything would matter. Well, it'll matter, but
it matters on premise.
Lots of moving parts, I guess.
Yeah.
The same pattern of these overlay VPNs and how you also do multi-region. So you can do hub to hub across regions with an overlay VPN as well. That way you put global peering in place, a bit cheaper, but you've then got to run a VPN between the two, because otherwise the route servers will know about each other and just share everything.
Have you done the same sort of thing with Megaport?
Yes. Megaport. Yes. Yep. Megaport was the ExpressRoute provider in the customer that I implemented from. Yep.
Actually, it's got me thinking in the sense, because the dual circuit, they allow bursting to go across the second circuit for every time. And so when that happens, is it technically a different endpoint, or is it just really terminating at the gateway?
I think you'd be abstracted from that, because that's just going to be dealt with Megaport on their edge and on like your routing edge too. I think you'd be abstracted from that.
The Microsoft Edge routers will probably sort that out.
Yeah, I just had a question around like availability zones. I know she didn't really talk to it, obviously, probably just keeping it simple, because already a lot of information. But with availability zones, how would you recommend deploying the FortiGate, and or also then integration with that gateway? What do you think there?
Template. Yeah, there are two different options. You can use an availability set to deploy across fault domains, et cetera, et cetera. But what we tend to recommend is using availability zones, because you're then isolated from a particular data center. You can have, one firewall in one data center and one firewall in another data center. So if there's an issue with a chiller, you can then fail over to your second data center potentially, and hopefully remain unaffected. The trick is then ensuring that all of the dependent components are also zone redundant. So you're when you deploy public IPs from a virtual machine, you don't get the option to select availability zones. So it's important to include that information in your template or to deploy the public IP as a discrete resource with that zone configuration and then attach it to your interface.
And so do you, like when you deploy it, do you deploy the FortiGate as a scale set or just individual virtual machines?
It depends on the pattern. Yeah, if you're choosing a scale set, yeah, you would deploy it as a scale set, and then add those in the template. You add those virtual machines to the scale set. But if you choose to go down the availability zone route to isolate yourself from a data center failure event, yeah, the individual virtual machines with different zone configurations.
I mean, we probably deploy virtual machines because licensing on marketplace. I don't think there's a certain license. Yeah.
Last time I looked at reference architectures, I didn't see something like this. The last time I saw about your bring your own firewall was the load balancing samples that you showed first up. To your knowledge, is there any later reference architectures replicating this? In the FortiGates, okay, not on Microsoft. Yeah, that's
no. So I mean, arguably part of the reason why we traditionally have not loved MBAs for the reasons outlined previously. But this makes the route server topology makes it work, and so they've got the Fortinet guys have got a reference architecture. That's where our template started from. That has all of this documented. So you're sort of following their reference architecture, but from a Microsoft point of view, I don't know whether there's a specific one for NBA plus route server. I don't think I've looked. Trouble would be.
Yeah, I'm sure they will
be using it within what it's meant to do.
Yeah. As I say, it's a while since I looked back, and I had to look recently too.
There is a Microsoft article that does the geo redundant route server stuff. So we'd probably be in a similar place.
There's a good John Saville video about HA and MBAs, which I haven't watched for a couple of years. I just looked up. It is pretty good.
Yep.
It covers the issues of load balancing. That's exactly you jog my back week tomorrow.
Yeah. Does it have server? There's an option.
I can't remember.
I think he touches on it, but it not in the detail that I would really want for something like this. Yeah. Good. I think it was quite new when he maybe made that video. It was probably a year or 2 years old.
Couple of years old.
Yeah. It's been a long time for you. Cool.
Wow, thanks guys. That was a fantastic presentation to end the year with. So
that's true.
Yeah, thanks very much. And as you may know, or been here before, but we always appreciate our speakers. But of course, we doubly appreciate.
Thank you.
Not only have you given us a great presentation, but also your company keeps the lights on with this group. So we very much appreciate that. So
thank you.
Thanks very much. And we do have one more bottle to give away, and that's because there is a gentleman that not only helps me with organizing these groups, but also every month he prepares all of the slides and his presentation of the latest news updates. So thank you, Daniel. And we also appreciate our Microsoft hosts. I don't have a bottle for you tonight because actually we scored by last month, right? Yeah. We appreciate Microsoft letting us use this phenomenal venue. So thanks to everyone. And I hope everyone has a safe holiday, and we'll see you in the new year. I think we've already got speakers lined up for the first 2 months. So stay tuned on the meetup site. Some people are away for holidays and stuff, so it's a little difficult to get the details up there, but we'll get it up there as soon as we can. And all I ask is when you leave tonight, if you brought a bottle or a cup or anything in with you, if you could just take it out with you, that would be phenomenal. And have a wonderful Christmas break.
You're going to rename the two no.
One day.
Right,
It seems too hard.